Welcome, everyone. This is our second seminar from the refugee program for the fall 2021. Today, we have the pleasure of having Dr. Dany Bahar. He's an associate professor at Brown University, Watson Institute for International and Public Affairs, and a non-resident senior fellow at the Brookings Institution Global Economy and Development Program. He's an Israeli and Venezuelan economist with affiliation to the Grow Lab at Harvard Center for International Development, CS Group Munich, and IZA Institute of Labor Economics. Dr. Bahar research sits at the intersection of international economics and economic development. In particular, he focuses on the diffusion of technology and knowledge within and across borders, as well as topics related to structural transformation and productivity dynamics. Lately, his focus has been towards migrants and refugees as an asset in the process of economic development. Today, he will be speaking about the global mobile inventor. So, Dany, the floor is yours.
Thank you, Teresa, and thanks everybody for coming or joining on Zoom. It's great to be here. I just moved to New England, and one of the parents, they told me, you're close to Yale and all those universities, and now when I get the chance to go to Yale, I'm going on Zoom, but next time. And thank you, Moshik, for the invitation. It's great to be here with you guys. So I know that this is a series about refugees, and I am doing some work on refugees, but this one in particular, I'm not going to talk about refugees, so it's going to be a little bit, hopefully it stands out. But of course in the Q&A, we can talk more about other stuff we're doing on the refugee aspect, but this is kind of a bit of a different crowd. And it's, I think, a very exciting project that we started. We just started, and when I mean we just started, is just 2 years ago before COVID. And this is joined with Raf Chaudhuri from Harvard School and Ernest Migueles from the University of Bordeaux, who I think is in the crowd. So if there are questions on the chat, I think Ernest will be, he probably has answers that I don't, so he will be able to jump in. Anyway, let me start a little bit with some, I guess, some motivation. And this quote we found from I think a philosopher, Carlos Cipolla, who said, through the ages, the main channel for the diffusion of innovation has been the migration of people. And of course, here one of the most notable examples is this generation of migrant scientists who arrived to the US. And you could very much say in a refugee status, the refugee status didn't exist really before World War II. It's attributed that these scientists in their many different fields really shaped or reshaped the whole science spectrum in the US and in the world. And there has been research done on this. I'm going to mention it, but of course the research by Petra Moser stands out, and it's pretty clear that despite the horrible circumstances through which these scientists had to flee their countries, the success of the US in this case, in everything that has to do with science and innovation, in a big part is due to this transfer of brains and of people who settled here. And I think this paper goes a little bit to speak about this. Let me start with one example of what is it that we're after at, an anecdotal example. Meet Ismail Mena. Ismail Mena, he is what I think is a pioneer inventor. He patented the first ever patent in Chile in the technology class A61B, which is a CPC classification in the USPTO, the US Patents and Trade Office. So the first ever patent that happened out of Chile in that classification was made by this gentleman called Ismael Mena. And the subclass A61B, of course, we don't know exactly what it means, but it's everything that has to do with instruments in terms of diagnostics and surgical and medical instruments, basically. After Ismail Mena patented this first patent in Chile ever in 1996, there were 70 more patents in that class by inventors in Chile. These are 70 patents by 19 other inventors in Chile that happened after this first patent. So, you know, one question I had is like, how did this guy do it? You know, how do you get to a country, or like you're an inventor and you start patenting something that nobody else in the country has done before? You know, it takes some, I don't know, courage, creativity. How does this guy do it? So I went and looked in, I mean, this is a cherry-picked example, of course, but I went and I looked into this patent. So this is the patent that Ismail Mena filed in 1996. It was filed in 1996. It was granted in 1998. We're going to talk about that later. But you see, it's a patent with a lot of people, some of them in the US. But Ismail Mena is in Chile. He's in Santiago de Chile. So of course you could say, well, you know, he was patenting with other people that knew about this and all that, and that's all fair. But stick with me for a minute for the motivation for the story. But what's interesting here is that when I go and I search more of this person, Ismail Mena, I found another patent in 1994, 2 years before, in the same subclass, so exactly the same technologies, where Ismail Mena was patenting in Los Angeles, right? So it turns out he was in the US, where maybe he did his degree, where he was working, he patented, he learned about this technology, and then he moved to Chile, which presumably is his home country, and then he patented more in that same technology. So our answer, and this is what I'm going to try to show you some evidence in this talk, our answer is, how did he do it? How did Ismail Mena was the first person to ever patent a new technology for Chile? Is because he was a global mobile inventor.
Dany, can I ask a question for clarification here? So the story, I mean, one way to interpret your story is that he is an inventor that wherever he goes, he invents and he takes inventions to a new place, right? Another way to interpret the story is that you move to a new institutional environment where you might not have necessarily a new idea, but in that environment, under those regulations, you might want to patent the same invention or the same idea that you had, right? That there's some value to patenting in the US, there's some separate value to patenting in Chile as well. And which interpretation is the one you would like us to?
If I understood it right, I think it's more of the first one. Are you, by the second one,
yeah.
are you saying?
The second one is like, there's not necessarily a new innovation that's moving to a new place. The same innovation, given a new regulatory environment, I might want to patent again.
I see. No, I think it's more of the first one, because these are all patents in the US in the same office. If that answers. So it's not that he's just replicating something in another country, but from Chile, he's now doing an additional patent in the same patent office. So it's something above and beyond.
I see. So when we move to the quantitative aspect of your work, it'll be holding constant the institutional environment, like in terms of like where the file depends. Okay.
Absolutely. Yes. Exactly. Yes. Mm-hmm. That's a great point. Okay. So I mean, I'm making here a big claim, and I'm gonna try to show evidence and to see how far we can get. So what do we do in this paper in particular? So we really explore this idea of what we call global mobile inventors, or GMIs. And we're going to try to answer questions such as, how common are these GMIs? How common are these GMIs, and how do they differ from other type of inventors? Do they really have very different characteristics? Can GMIs explain the emergence of new technology classes in the countries they go to? And this is, as Mutrik said, yes, keeping constant as much as we can, including the institutional environment. what else can we learn about GMIs being pioneers and in the process of diffusion of knowledge and technology? And here I'm going to be honest and upfront, and please keep bringing up these questions. We in this work in progress, we don't have yet a fancy identification strategy. I'm not sure we really need it because in essence, I think a lot of what we're trying to do is really descriptive, to try to show the evidence of who are these people. And I think we have some pretty strong and robust patterns that makes it interesting. However, I'm going to talk about that. We are still trying to see if there's room for improvement when it comes to identification. And of course, we welcome ideas on that front.
I have a question.
Yes.
So does it matter if the movement of the GMIs are volitional or non-volitional?
Are voluntary.
Volitional, like, if they intend to move or they were forced to move?
I mean, it matters in terms of endogeneity, of self-selection, right?
Yeah.
If that's where you're going to.
Yeah.
Of course, it does matter. And I think that's going to be your biggest challenge. But here, without getting too much ahead of time, there are kind of two views of the world here. I mean, one of them would be, let's imagine a firm wants to start patenting in something, that they don't have the local know-how or the local skills to do, and they will actually bring somebody from the same firm, from another location, from another firm. That is a self-selection process, happening in process. The question is whether, that still means that the counterfactual is that firm wouldn't be able to continue patent without that person. So, we don't want to make a strong claim about that, but I am putting up front here the fact that, we're not coming here with saying like, this is a perfect identification. There could be important selection issues. We try to show, we try to go as clean as we can, but your point is great. And yes, I mean, most of these moves are going to be voluntary.
Thank you.
I hope, though, that you still find cool and interesting what we're going to find, even though we do have room for improvement in terms of the identification strategy.
So at the macro level, it's like, the evidence is quite clear that, like, movement of European Jews to, let's say, America led to a lot of innovations,
Right.
But at the individual level, I have not seen the evidence. So I'm very curious. Thank you.
Yeah, so I think this is an attempt of doing that. I think that the work by Petra Moser and the work by, I have special mention to them, by Shai Bernstein and Stanford and co-authors, show a little bit of that on that direction, but not so much on the emergence of new technologies. They measure the knowledge diffusion through other means. And I think we're going into that direction, as you said. All right, so some of the main findings to put out there. So first of all, we do find that these GMIs are superstars. And I'm going to show you a table that specifies this very clearly. They have longer careers, they patent much more, they patent higher quality innovations. So there's, of course, something special about them. What I think is our main and most important result is this one, and is that GMIs are significantly more present in the first stages of the development of a new technology class in their countries of destination. And I'm going to show you a lot of evidence about this. And it goes back a little bit to the example of the beginning of Ismael Mena. We also find that this prevalence disappears over time. So like as the life cycle of the technology advances, we see less presence of GMIs, which to us could be interpreted as a sign that once the knowledge has been transferred, as more and more patents are being invented in that technology, the knowledge becomes embedded in the local inventors. And once I get to that graph, I'm going to be more specific about what I'm saying. We don't find strong evidence, though, that the quality of the patenting significantly changes when there are GMIs involved in the first few patents of a technology in a given country. So we do find that the technologies start off with a higher presence of GMIs, but when it comes to quality, as much as we can measure the counterfactual, we don't see a difference. All right. So it's very hard to do justice to a very long literature, but a little bit of what we think is our main contribution. First of all, on this huge literature on the globalization of innovation, there's a lot of papers showing that innovation is becoming more globally integrated. There's many more patents that are global collaborations. There's a lot of cross-country citations. And also there's a lot of recent evidence, but very growing and very fascinating that a lot of the innovation is happening thanks to immigration flows. And we have here a long list. And I think here that our particular contribution is that we come and provide evidence of a new aspect of globalization and go very deep into this phenomenon called the GMIs, which is like really studying the people, these innovators that are moving across borders, and how are they shaping innovation in the countries they arrive to. Much beyond citations. A lot of the focus on this literature has been on citations, how knowledge transfers through citations. We're actually looking more at the emergence of new technologies. And of course, in that sense, there's a long literature on human mobility and the diffusion of knowledge. And Sanjeev also mentioned that there's good, it has been very well established, more at the macro level, that the role of scientists, migrants diffuse know-how and technologies, and there's a long list. And as I said before, I think there's a special mention to the work by Petra Moser and co-authors and Shai Bernstein and co-authors, who really look at the evidence, more micro of immigrant scientists importing knowledge. Shai Bernstein and co-authors do it more with citations, and Petra and co-authors do it more with scientists as opposed to inventors and patents. In a few words, I think we are really bringing some, the universe of patents using microdata to measure the emergence of new technologies through diffusion. And this builds a little bit on a previous work of ours with Raj Chaudhuri and Rappaport, who we do this a little bit at a macro level. Okay, so the data we're going to use is our main data source is PatentsView. PatentsView is a website or a data visualization tool that is maintained by the Office of the Chief Economist of the USPTO and partners that includes several organizations and universities. I think the University of Amherst is involved here. And I'm going to tell you what makes this very special. If you don't know about it, the platform contains the universe of patents granted by the USPTO from 1976 to present. That doesn't mean, these are granted from 1976, so you might see patents that have been applied to before 1976. So in essence, what makes this data set special is that they use some complex algorithms, some machine learning, to disambiguate the names of the inventors and of assignees, which are the firms that the patents are assigned to, where they most of the time if an inventor is working with IBM, the inventor is listed on the patent, but the assignee is going to be IBM, for instance. So we have a unique identifier for both. So basically, we can really track inventors across time and space. So each time an inventor will patent an invention, that inventor will list his or her address at the time of filing, and of course the assignee. So we can really see all the movement of people as long as they're patenting, which is important, right? So as long as we see patenting activity, we can really see mobility of people across borders. Or, we can do it across cities if we wanted to. In this paper, we're focusing just across borders. And of course, we can identify assignees, and firms, which is important because we don't do a whole lot of that right now, but we are also looking a little bit about, and maybe Sanjeev, this goes a little bit to your question, not exactly, but we are looking a little bit into movements within the firm or across firms, and we see some heterogeneity there. But of course, we have much more information to work here if you wanted to. So our sample, we actually gonna limit our patents to that have an application date between 1970 and 2015. So as I said before, the patents are granted starting in 76, but I could have filed a patent in 1970 that was granted in 76, or vice versa. There's a patent that was granted in 76, but it could have been applied, I could have filed it 10 years ago, 10 years before, or 5 years before. So we have all these. We stopped in 2015 just because often we use like citations measures and to avoid like results being biased by right tail censoring. We just try to cut it a little bit because you do see like towards the end of the sample, you see a lot of right tail censoring of many measures, but none of this is really changing our results. So when it comes to when an invention is happening, we're going to use the application date or priority date if earlier. So again, the application date is when I go to the patent office and say, I want to apply with these patents, like when we, the submission date of the journal, right? Which is different than the publication date. There are certain patents again, we're using here only the USPTO, so the US Patents and Trademark Office. So we're using only one office. And of course, there are inventors everywhere in the world that can patent through the US office. Sometimes these inventors also patent in the European Patent Office, or they're also patented in the Japanese Patent Office. And when this happens, if you patented, let's say you patented first in the European Patent Office, and then you patent the same invention in the USPTO, so to have more jurisdictions, we actually going to use the date of the first patent that you filed. In this case, the European Patent Office, right? So if we have a priority date that is earlier, we're going to use that. And this is pretty standard in the literature. We just do it because that's the time that most closely resembles when the innovation actually happens, as opposed to the granting date. This is just like admin, right? I'm going with you. So our sample includes about 6 million granted patents, and they belong to about 15 million inventors. And each patent is classified to a technology subclass according to the CPC codes, which is the one that USPTO uses, which is the cooperative patent classification. These are like 4 digits or 4-character patent classes, and there are about 623 of them. So every time I'm talking about technology class or a technology subclass, sometimes I mix the two, but I'm referring to these. I'm referring to the 4-digit CPC codes. And we are gonna complement. I'm gonna talk about this later. We complement this with some quality level measures from OECD data set by Squarciarini, Dernis, and Crisculo. Okay, let me start showing you some data. Interrupt me if there are any questions. So this is, for instance, just simply like how many patents are filed per year in our sample from 1970 to 2015. Of course, at the beginning, there are very, very few because patents view starts only with patents granted in 1976. There's very few patents that were filed in 1970 and waited 6 years to be granted. So of course, at the beginning, there's very little. But overall, this reflects, I think what we should take from this graph, it reflects that, during the 90s, as expected, there was a huge boom in innovation in patents filed all over the world. So this is kind of what we're working with. Okay, this is a very cool graph that is not exactly what our sample, but I thought it was cool to show. And this is basically where are the inventors. And this takes the USPTO, it takes inventors from other offices, and basically, with geocoded data, you see where actually the inventors located. And no surprise, most of them, of course, are in the US, Europe, and Asia, and East Asia. and very little across the developing countries. As we know, most formal innovation happens in these countries. Oh, this is not showing. Anyway. Okay, so I'm sorry that the legend here is not complete. So basically, this is another graph showing a little bit which one are the, in which countries are the inventors that are filing the most in terms of countries as a whole. And this is basically showing you, the US is this purple line. It doesn't show in the legend, but the US, of course, is the number one filer of patents, or inventors in the US are the number one filers of patents. Then you have Japan, if I'm not mistaken. Then you have Germany. China is this green line that you see how it's rising very rapidly in the past 2 decades. Anyway, just some descriptive statistics for you to see, but just to show you kind of a little bit the extent to which we have data.
Can I please ask a simple question?
Yes, please.
So can you trace these inventors to organization that they were part of?
Yes.
Okay. So do you have any sense, maybe in Japan, it's a more self-employed inventors who are active, or in America, it's more organization-based? Do you have any sense about?
I don't have a sense right now, but that's very easy to find out. I mean, I can follow up offline. My sense is that most of them, I think that they're very, Ernest is in the crowd, so maybe he can write it in the chat, but he knows this data pretty well. But I think that most of these patents are, you mostly always have an organization behind you. It could be a university too.
Mm-hmm. Okay.
But I know that multinationals account for I don't know if 80%, but a big chunk of the patents that are filed. So I think most of them actually do belong to an organization.
Okay.
But that's easy. That's really easy to look in this data.
Okay, thanks.
All right. So let's go to the meat here. So who is a global mobile inventor? How do we define him or her? And we here have to make a little bit of some arbitrary decision. So basically, the short answer is any inventor who patents in more than one country throughout his or her career and hasn't moved across borders, we classify that person as a GMI. This doesn't mean this person is a migrant. We are aware that we can't, with this data, classify somebody as a migrant or not, because we don't know the country that they were born in. There were some databases on the European Patent Office that had your nationality. We don't have that here. So we're not making a big claim about migration, but it's fair to think that a lot of these people are actually migrants. I have a question.
Hi, Dany.
Hi there.
This is AJ. I have a quick question. So by the way that you're defining a GMI, this to me sounds like by definition, you're excluding people who would, for instance, come to the US, study in the US, get their PhD, whatever, and not have time to, let's say, apply for a patent and then start working in a place like Google and then actually be incentivized to apply for a patent there. So you're essentially missing out on a group of younger generation who get into that stage of applying for patents a little bit differently. So could you speak to that a little bit more, and what do you think this type of exclusion does to your results?
Yeah, no, that's a good point, and we are. I mean, I think your story, if somebody, I'm an immigrant in the US, and let's say my first patent is in the US, and I don't move anywhere else, I wouldn't be a GMI in this data set. We do have, and I'm going to get to that, some name analyses where we kind of try to, based on your location and your name, try to say something whether you are an immigrant or a returnee. And we do some work with that, but I don't have a great answer for it. I mean, it's a great point. I take it, and you're right. You're absolutely right. We're not, for you to be, let me even go one more step there. For you to be a GMI, you need to have at least 2 patents. Right? You can't.
Precisely, both in your home country or wherever you start from in another place. And if we follow this logic that you just opened up as well, if you're coming from a country that has heavy regulations on patents, applying for a patent, then by definition, you're excluding very low income settings.
Absolutely, no, I agree. I mean, I guess that the boring answer to your very good question is like, that's why we're not using the term migrant. It goes very far. We're using mobile inventors as people who actually we know they're inventors and move around. It's hard for me to say how that will kind of bias what we're doing. I mean, if anything, I guess it could underestimate what we're doing.
I think you may be overestimating how creme de la creme these people are, because you're essentially removing the people who are earlier on in their careers. So you're really comparing people who've had the chance to both apply for a patent in their domestic or wherever, and then somewhere else. So you're really, really looking at people who are top achievers.
Yeah. So when I'm gonna show you the first comparison in a couple of slides, and we do. I mean, this is not perfect, but it kind of goes a bit to your point. It's like we compare them to other inventors that also have 2 patents, just to make it a little bit more apples and apples. But you're right. I'm not evading your point. This is a limitation. We're and we have to keep. I mean, we're open about it, and we're not going to claim otherwise. You're absolutely right.
Thank you for responding so kindly.
Yeah, of course. Okay, so bear with me that we're going with this definition based on the data, and then a question arises, which is like, okay, you are a GMI, but for how long are you a GMI? Are you a GMI for the first hour since you moved? And I mean, so for the first patent, are you a GMI forever? Are you a GMI for 6 months, for 2 years? We have to define some framework to do it, and here I'm actually going to show you how we do that with a cartoon. There you go. Doesn't look great, but anyway, so let's say we see this inventor. She has a patent in country A, right? And we're going to have 3. We're going to be using 3 definitions of GMIs. In year 1, this person patented, so we see her in our data. Then we see her again on year 3 on country B. So she, we assumed, and I think it's a fair assumption, she should have moved in between year 1 and year 3. And just to keep it simple, we're just doing this example where this person actually stays in country B. We can have people moving around, and I can answer questions about that, but let's keep it simple for now. So we have 3 definitions. The first one, let's say, is a GMI just for the first patent. So we count you only as a GMI when you do your first patent in another country. And if I see you patenting again in the future, you're not a GMI anymore in our sample. That's definition number 1. Then we have what I think is kind of the moderate one, which is GMI for 1 year, which is like we count you as a GMI after you move. And every time you patent within the first year, you're still a GMI, right? You're still like, just came, might be in the process of bringing the know-how, et cetera, et cetera. And then we have kind of the most, I don't know if extreme, but the most, the largest definition is like, well, you have a GMI always, which is, it doesn't matter what happened. As long as you moved once, you're always a GMI. We have to set some structure, and this is the way we went through it. For most of the results I'm going to tell you today, I'm going to show you results with the 1 year GMI definition. Everything is really robust with all of them, but we just have to stick to one for. I don't want to show you 3 tables every time for everything, but we're using this definition and just to set the stage. Okay. So let me show you a little bit more data. So tell me if that wasn't clear. This is important, right? I guess if there are any questions, just jump in. Okay, so this is just a snapshot, basically, of the top 50 corridors between 2015 and 2019. So basically, what this graph is doing is showing all the movements that have been between 2015 and 2019 in the top 50 countries that have movements. These actually should be, these are not 50 countries, these are, I think, 20. So that's a typo there, I'm sorry. So, I mean, basically what this graph is telling you, this is the US, this blue, you know, this blue part here is the US, and these blue lines are all the inventors leaving the US, moving out of the US. You see a lot of them are going to China, a lot of them are going to Canada, a lot of them are going to Japan, et cetera, et cetera. It sounds like, you know, you could think, and we do find evidence of that these are kind of returnees who are returning. China is a big country of origin of many GMIs, a lot of them going to the US, but also to Taiwan, interestingly, and all over. Okay, so this is kind of a glimpse of the richness of the data we have. I have a lot of descriptive graphs, so I'm gonna, for the sake of time, I might need to skip some, but this is also like how many movements are year to year in our data set. So you see, in the latest years, first of all, you see that this is a growing phenomenon. I mean, in the 1990s, as compared to today, I mean, the numbers of international movements of inventors have quadrupled. So it's a really rising phenomenon, which we think is really important. And, you know, a smaller share of all these movements are people moving within the firm, but actually most of them are moving across firms. This is something we can do, Sanjeev, with what you were referring to before, the fact that we can really track assignees to our firms with a unique identifier. This is interesting. I wasn't really expecting that most of the movement will be across firms. This is too much information here, but just I'll walk you very quickly. I mean, these are the main corridors of movements, you know, per 5-year periods. So you start seeing that the first corridor in the 80s and the 90s was from Great Britain to the USA, and then it changed from USA to China, which is really interesting. And you start seeing really a lot of changes in the past 20 years of how things are moving. So now let me go to, this does not make justice to Edge's previous comment, but I think it's kind of a step on that direction. So again, we're not able to explicitly define a GMI as an immigrant, but we do perform a name analysis for those purposes. And I think you probably have seen many papers doing this. We're not doing anything very new, so I'm kind of going to go a little bit fast over this unless there's questions. But basically, you know, with several algorithms, basically we rely on the IBM Global Name Recognition System, which is based, and Ernest is here. Ernest, who's my co-author, he's here and he did this, so he might correct me. This is based mostly on names of people who are immigrating to the US. So this is mostly for outside of US names. So using this data set, we can actually track and give a probability essentially of the country you are from, both from your first name and your last name. So, you know, we take the names from Patents View, this name, for instance, Laroya Raiv. We know that the surname, you know, has 99% likelihood of being from India, 1% likelihood of being from France. And the first name, 81% likelihood of being from India, and these are the other countries. So based on this, we actually define, based on your last name, what is your, the country of your ethnicity, if you may. Using this, we kind of, we do our best. This is not a perfect algorithm, but we do our best to mark you, if you're a GMI, as an immigrant or as a returnee. So what does that mean? Wei Rao, for instance, who's in our data set, and he has, for instance, 3 patents, as you see here on the left, is the same inventor, has the same inventor ID, and he patents the first 2 patents in China and then moves to the US. So he is a GMI, and we mark him as an immigrant in the US, and not a returnee, right? Because his last name and his name resembles names in China. This is kind of the easy case. Also, we have, if the GMI is coming in the host country, we mark that person as a returnee, right? So Marco Paniello patented in Great Britain, and then we see Marco patented from Italy, and this name resembles an Italian last name, so we count that person as a returnee. Then we get into more complicated things that I'm going to skip, because then what do you do if you know, anyway, I'm going to skip this part because it gets a little bit complicated, but I'm happy to talk about it offline. That there's a bunch of cases and we try to make justice, but in you know, in the big scheme of things, the point here is we do our best to try to define if a person is an immigrant or returnee based on names. When we do that, and here I'm showing you again these corridors, you know, things kind of change a little bit. So you see that when it comes to immigrants, we see that you know, traditionally the most common corridor was from Japan to the US. Then in the mid 2000s, it becomes from China to the US. You know, also you start seeing like you start seeing the US as a recipient country much more often. And when you look at returnees, you kind of, the picture turns around. So you start seeing the US as the sending country much more often, and the receiving countries, you see China, Korea, and you know, Germany, India. You start seeing India in this top 10. So you start seeing also some developing countries. All right, so this to me, I think it's a very important graph. And here, if I haven't convinced you already how important this phenomenon is, I think that this graph, at least to me, it's convincing. Here, basically, we're comparing how frequent, how many patents, or what's the share of patents that have GMIs across time. And here we're measuring GMIs with the 3 different definitions. Of course, when we use the most generous definition of always, you know, the share of patents is very, very high because it accumulates people. But here we're basically comparing the share of patents of people who are GMIs to the share of patents that are GCPs, which are global collaborative patents. There's a very important influential paper by Bill Kerr and Sadi Kerr, showing this important phenomenon of these global collaborative patents that are filed by inventors living in 2 different countries or 2 or more different countries. You know, they claim it's a big phenomenon. It's a great paper. You know, you can learn a lot there about this globalization of innovation. And here I think we're showing that when we look at GMIs, it's a very comparable phenomenon when it comes to its size and velocity. So I think that this was an important graph for us to you know, a little bit to compare apples with apples. Okay, this is going slower than what I thought. So I do want to try to get to the results, but this here is kind of what I'm trying to show. You know, who are these people really, and how do they differ? So for a bunch of different measures here, I'm not going to go through all of them, but like how many patents you filed throughout your life, in how many countries you filed throughout your life, how many firms did you work with, or like how many assignees are your patents, what share of your patents are patented for the top 100 assignees, for the firms that patent the most, how many active years you have since your first patent till your most recent patent, and a bunch of things, including some quality measures and so on. This is the mean for GMIs, this number for the average GMI. So the average GMI patent 17 patents throughout his or her lifetime. It patents in 2+ countries throughout his or her lifetime. It patents for almost four different firms. Half of their patents, or almost half of their patents, are in the top 100 assignees. They're active for almost 15 years, right? And then you have a bunch of other measures, and you know, their quality, it's also quite high as compared to the 2 followings that I'm going to tell you. So the first 2 columns here is like comparing to the average non-GMI. So everybody who's an inventor who doesn't move, of course, here, you know, the country, if you're a non-GMI, by definition, you only have one country, right? And here, to make a little bit of justice towards what Ege was saying before, which is a great point, we are comparing it also to people who patent 2 patents or more, because maybe the superstars doesn't come from the fact that you're moving. The superstars come from the fact that you patented more than once. And even there yet, we do see important differences. So these deltas here are the differences between these GMIs and these non-GMIs. And, across the board, these GMIs are really superstars, patenting higher quality, patenting for longer time, making more patents, working for bigger firms, et cetera, et cetera. All right. Let me go a little bit more into a little bit more rigorous empirical work that we're doing. So one of the main questions that is driving us is like, what role GMIs play in the life cycle of a country and a technology. So what we do for this is that we basically sort for each country and each technology class. So think about, each country and each 4-digit technology, we sort chronologically all the patents within that cell, right? From the first ever patent ever for that country in that cell. For instance, in Chile, in medical instruments, the first one would be the patent by Ismael Meno, we saw at the beginning. And then we sort them chronologically until the most recent patent we have in the data. And then we just simply divide it in 10 chunks, like 10 deciles, the first 10%, the second 10%, the third 10%, and so on. So we estimate, we want to try to get a sense of how frequent or how likely it is to see a GMI in each one of these deciles. The first decile ever, the second decile, and so on. But we want to add, we have enough power to add some controls. We don't want to do just a simple average. So basically what we do is that on the left, we run a regression. On the left, we have like a binary variable whether you are a GMI or not. Here we have a set of dummies per country and technology for the 10 deciles, okay? And then we add some country year fixed effects, some technology year fixed effects. And we do a lot of more robustness tests, but this is what we find. I think this graph to us is kind of I don't know about you, but I really like it. So this is what this graph is showing us. This graph is showing the probability of seeing a GMI for the average country and technology in each one of the deciles of the life cycle of that technology in that country. So what you're seeing, everything is relative to the most recent decile, so the latest 10% of patents. Of course, here we have, we only keep countries and technologies that have at least 10 patents. So what we find here is that in the first 10% of patents ever in a given country or a technology, you have a little bit more than half a percentage point higher in the likelihood of seeing a GMI than in the most recent decile. You still see that in the second decile, you still see it in the third decile. It starts the significance of the estimate starts disappearing after the fourth decile. So after 40% or after a few patents in the country, it seems like GMIs are not present anymore in the life cycle of these patents, which could be interpreted, and that's our interpretation, that as time goes by, the ability to keep innovating in that same technology is fully embedded in local inventors, not in global, not in GMIs.
Dany, here, could it be just the same inventors that say filed the first patent, but because of your definition of GMI, they just stop being considered GMIs? Or is that ruled out? So
we try this with all the 3 definitions, and it's robust. So if you use the always definition, which is the most exhaustive, actually it's gonna look even stronger, right? So I think that the significance will disappear maybe later on. But if you use only the first patent, you will still see a presence definitely in the first decile and weaker afterwards, but you still see the pattern very strongly. Okay, I'm just gonna skip this. This is just what I said. I mean, this is robust to using different GMI definitions, using even stricter fixed effects, different levels of aggregation. We can aggregate everything at the patent level. You know, it's pretty robust, remarkable.
Dany, this is Ece again. Can I ask you a question?
Absolutely.
That was a fantastic graph. I love this. And just in terms of trying to hypothesize a little bit about why this might be happening, do you think this might be partly driven by like the country's specific policies in helping out with immigration policies? For instance, let's say quantum physics may be an area of interest right now for the American government, so they make it easy for the inventor to move. At a stage, let's say like when quantum technology is in a more nascent stage, etc. I'm just giving you like a toy example. What do you think might be driving this? This is such an interesting result.
So I'm gonna try to I mean, with this method, I will welcome many ideas because I'm limited a little bit on the controls I can put. But so then now we're moving. I'm gonna move to some more tables that I think is getting into that. The very boring answer to your question from me, which is not 100% yet, is that, you know, we do use here country year fixed effects, technology year fixed effects. You're talking about a country technology year fixed effect kind of thing.
Exactly.
We do put here country technology fixed effect, and it still holds. It kills a lot of the variation, but it still holds. It certainly can be, you know, it certainly, what you're saying, it certainly can be an issue. And yeah, so that's why, you know, if we can tackle a bit better identification, it will solve that. But it's a great point, and I don't think we can go that far into that to claim that that's not explained by that. But you're absolutely right.
Then one more question. So would this graph look similar if you were looking at GMIs who, like according to this technique of using names, are immigrants, like thinking that maybe diffusion happens faster if you're returning to your home country versus if you're not?
So Ernest, I'm gonna call on you too. We did a lot of this at some point, and I think we didn't really find big differences between the two. But I might be, I don't know, Ernest, if you want to jump in or you want to put it in the chat, but if you think I'm wrong, but we didn't find significantly difference between the two. I mean, we do find that the effects of returnees, I'm going to find, you're a little bit stronger. But in terms of the diffusion, if that's what you're referring to, I don't think we found like significantly different effects. But you know, we're still, we should definitely check out again. I'm calling Ernest all the time, even though he's in Europe. So, and he says we did not find differences in the graph between immigrants and refugees and returnees. Sorry. All right. So I mean, this is not exactly gonna get to your points, Ece, but I think again, it's a step on that direction. So I think that the way we try to really tackle this relationship we're seeing in the graph in a more rigorous way is by changing a little bit the way we're estimating this. And basically we're gonna start, I'm gonna show you a lot of tables with this regression, estimating this equation here in the middle. And this equation basically, so a little bit changing the terms. I know we're not supposed to do that in theory, so forgive me, but we are like, we're trying. But basically what we're doing here is to actually look, now our dependent variable becomes patents that are in the first decile. So which you know, a dummy, if this patent that we're looking at is in the among the first ones that we're looking, that in that technology and country. And to the right, we have also a GMI. I should have said, and I forgot about this, this is really important, that the GMI, did I say it here? Yes. Do you see here how there's something that says here previous experience? So it's not, we're not only measuring your GMI, we're also measuring, we're also assigning a 1, not only if you're a GMI, but also if you patented in that same technology before you came. okay? So we're a little bit more strict. It's not only about whether you moved, but whether you moved and you already have experience working in that same technology, okay? So that's a kind of an additional level of detail that we're going here when we're doing these relationships. And I'm sorry I didn't mention that before. So we have, patents on the first decile. Then we have, our main variable of interest, whether you are a GMI with previous experience. We have some controls at the inventor level and at the patent level. And then we had a bunch of fixed effects. I mean, here, I think in the baseline, we only have country year and technology year. In the robustness, we have a bunch with technology, country. And I have to see, Ej, based on your question, if we can go as deep as technology, country, year. I don't know if we have enough power for that. We also add here in the baseline a fixed effect for assignees. So like, if you're patented for IBM, we're going to have a fixed effect for IBM. Just because you might say, well, maybe the person is moving within the firm, or maybe the know-how belongs to the firm somehow, and the inventor is just executing, right? So that way we're trying to getting rid of that. And actually, by the way, this should be assignee year fixed effect. Okay, so it's even more strict. And the controls, which I'm not going to show you, but they have a bunch of things such as the number of non-patent literature, the number of claims, the size of the team, the foreign priority, whether there's the size of the lag between the filing date and the granting date, a bunch of things, okay? Okay, so this is what we find. So first, the very simple regression, where we find that yes, being on the, the likelihood of being of a patent being, or having a GMI explains with much higher likelihood that your patent is among the first ones, is in the first decile. This is what this estimator is seeing here. I'm trying to understand better the economic. I have to admit, I was running this last night, this regression, so I'm still not there yet with the economic interpretation. Because it seems to me a little bit small economically, to be honest, because if the likelihood of being in the first decile is by definition 10%, this is increasing this by 0.2%, by 2.2 percentage points, so it's not huge, but I'm still working on this, so I'm not gonna get into that. But we do find that as compared to the other 9 deciles, and remember, this is a bit of a stricter test because we're comparing the first decile with other 9, right? So as compared to the latest 90%, there's a much higher likelihood that if you're a GMI, you're patenting in the very first decile, okay? And here we're controlling whether the patent is a GCP, a global collaborative patents, and all the fixed effects I told you before. Here we're kind of putting in the same regression, and this refers to what I was saying before, like if you're a GMI with the previous experience, but also if you're a GMI without experience. So you just move countries, but you never worked on these patents before. And when we put the two of them together, the explanatory power remains on those people that actually have the experience on that same patent, which we think is a nice quasi-placebo test here. Then we are kind of dividing whether you are moving within the same firm or moving across firms, right? And here we really don't find there's no big difference. But Diana, a little bit to your question, not exactly, but here we do find that when it comes to a returnee, it's almost twice the magnitude than when it's just an immigrant. And I don't know if this is a special power of returnees, or is it that most returnees are going to developing countries where there's some more, I don't know, there's more room for convergence and more technologies can be can emerge. So that's kind of our interpretation. Okay, so this is kind of our main result. We're doing a lot of robustness, stricter fixed effects, aggregation, disaggregation. Coefficients seem to be very stable. We still find that coefficient seems to be very strong and robust. So what is this? Okay. I have to admit, I was playing around yesterday to try to show you a little bit more heterogeneity. It's not a very exciting table, but I show it to you anyway. So basically what happens, for different subsamples, if we look at this relationship with the same specification. So, the first row is what I just showed you with, this has, by the way, I don't know if you noticed, it's 15 million observations because we are doing this at the inventor level. So this is the same estimator we saw before. When we, for instance, divide between whether the host country is a developing or a non-OECD country versus OECD, we do see there's many less observations in non-OECD countries because most of the innovation is happening in the rich nations. But nevertheless, we still find a bigger point estimate by 50% in non-OECD countries, which I think is consistent with this idea of returnees. Most of them perhaps going to developing countries when there's more room for innovation and for new technologies. We kind of divide this by periods. We didn't find anything there, but I'm not very surprised because these are very short periods to really study the phenomenon. People might, we might lose a lot of variation of people moving between 2009 and 2010, right? So there's really, I don't think it makes a lot of sense to divide this in periods. And when we do this by types of technologies, we do find, I don't think this is terribly interesting, but patents on electricity, they seem to be there. The 89 observations of general tagging seems to have a very, very precise 0. And patents of human necessities, which I wrote down what that means. Human necessities are, where is it? Agriculture, food, health, clothes, personal items. So I think most of the things that we use in a day-to-day, these things seems to, explain a lot of this diffusion of know-how. So, we're trying to figure out a better way to do this heterogeneity analysis, but this is kind of a direction we're there. And actually, it seems I'm going to finish before the end of my time because I just have one more result, which is on the quality of innovation, right? So I think an important question that remains is, I kind of show you the stylized facts that GMIs patent much higher quality innovations. And quality, meaning innovations that are much more cited, innovations like patents that are more cited, patents that are more original. We have a bunch of metrics, I'll show them to you. To me, at least, or to us, I think most importantly, the question is like, if the knowledge is being imported, to what extent, that's reflected in quality, right? So kind of like, does the early presence of an experienced GMI in a country technology life cycle translates into a higher quality patents in the future? Like, is there a path dependence kind of thing? Like a GMI premium on quality for the rest of the life cycle of the innovation. And to do this, we rely on this. I mentioned it very briefly on some quality measures at the patent level that was put forward by a team in the OECD. We're using like these measures like forward citations, which is the most common measure for innovation, something called breakthrough, generality, originality, radicalness, and an index that takes all of them together. I can go through all of them if you have a question, but I have them all defined. But these are, just different measures of quality of a patent, how important they are, how innovative they are in their technologies, how much do they rely on other technologies, how much do they open the door for other technologies, all these kind of things. And basically the question we're trying to answer, the best way we found in trying to answer, and there's also some maybe there's a better way, and I'd love to hear about that, is basically what is the average quality per decile if in the first decile there was a higher presence of GMIs. Okay, so it's basically kind of interacting each decile with the share of GMIs in the first decile. and I'm not going to show you tables. I'm going to show you a graph. And the answer is that we don't find anything. I think you would start to be suspicious if I show you I have results for everything. So I'm showing you something I don't have results for. So here basically, this is the average quality in each decile in the left graph, and this is the GMI. If there was a GMI in the first few patents, what is the average quality? What is the GMI premium? And even though the coefficients are higher, they're not precise enough to be able to say something. So there's really no difference in quality. This is just with one measure of quality, which is this index that has all of them. But it doesn't matter which quality measure we use, we don't really see a lot of differences. So that's we can't conclude anything very special about GMIs playing a big role in the initial stages and also playing a big role in the quality of the innovation in the future. We just don't see any difference. Needless to say, this is also done with all the fixed effects and all the controls, et cetera, et cetera. So let me actually start to wrap up, and then maybe we can have some time for questions. I would love to hear your suggestions because we need a lot of them. So basically, what we're trying to do here is to contribute by continuing to uncover a phenomenon of growing importance in the globalization of knowledge, of the production of knowledge, which is this global mobile inventors that we believe is an under-researched phenomenon. And we find that they play a critical role, both immigrants and returnees, in the diffusion of knowledge, as we measure it, which is through the emergence of new technologies, but they don't seem to define some sort of quality path dependence. And in terms of next steps, we know that we have challenges with identification. Some of you raised here, and I totally agree. So we did try some ideas on try to kind of instrument perhaps for the movements and so on. They weren't very terribly successful. We are looking also into other methods, maybe looking something into an ordered probit, not to be so harsh between comparing the first decile to the other 90%, and being a little more precise than that. And some things that we're looking in the future, some of them we started looking already, is to think about recombination of technologies, whether GMIs are playing a role in countries combining technologies, not just by looking at at the main technology code of the patent, but all the different technology codes that a patent could have. Looking into whether this diffusion process changes, whether the first few patents are mixed teams or not. I mean, is the GMI working on his or her own, or is the GMI working with local inventors? Does that play a role in the diffusion? We certainly need to play more a little bit of heterogeneity and the sizes of firms, and also some more inventor heterogeneity in terms of demographics. So anyway, I'm going to stop here. I thank you very much. I know, again, this is, I don't want to say it's a purely descriptive paper, but I know that we have some challenges on identification, but we still think we're adding a lot of value just by really describing this phenomenon and getting as deep as we can. But I will welcome more of your so far excellent comments. And thank you for being here. Thanks for listening.
Dany, quick question. Very interesting, by the way.
Yeah.
I remember seeing at the Bernstein paper some impact of the immigrants on citations and the market value patents and top patents, and I was a little bit puzzled when you showed the no impact on the patent outcomes, and I was thinking if it maybe something on selection, maybe once of the migrants versus the GMIs, or I don't know. I wanted to get your ideas on what you think could be explaining the difference.
No impact on the quality measures, you mean?
Yeah, on the citations, on the forward citations, or on, yeah.
We do see that GMIs on their own, their patents are of much higher quality. That we see. We're trying here to get to something that I don't know if it's a stretch, but it was like, are they setting up like higher quality for the rest of the people who are patenting that content technology. And that's where we don't find anything, right? So like, if you remember the example I gave at the beginning of this Chilean scientist, Ismael Meno, who came and did one patent, and then I said that there were 19 other patents that happened after him. We don't find these 19 other patents were of much higher quality than they would have been, if you believe, being a little bit exaggerating with identification, if they would have been, if Ismael Meno wouldn't have been there. That's what we're getting at. So it's not inconsistent with the fact that immigrants patent higher quality, or GMIs. We're trying to get a little bit beyond that and seeing if there's a path dependence of quality for the rest of the life cycle.
Yeah, from the diffusion component. I was just thinking that the immigrants that were coming permanently are more likely to have that effect, right? As opposed to the ones that might be returning. But
right. So here we're pulling everybody together, not only for patents by immigrants, but patents by everybody. So we could do that. We could try to define, we could look into that. Thank you. Yeah. Mm-hmm. Yes, Ajay.
Hi, I'm very vocal today, but sorry. So one question I had was that, so what you're trying to explain is that does the existence of a GMI influence the quality of patents in the subsequent periods? Another way of looking at the question, maybe, in which you may have already looked at it, whether is that maybe the same quality of patent was going to arrive, but maybe the time it took to get there may be shortened. Did I clarify myself? I'm not. So it's a question of, not a matter of whether it was going to emerge, the same quality would have emerged or not. It's that would it have emerged in the same pace in the absence of a GMI?
Yeah, no, that's possible. Yes, that we're seeing. I mean, yeah, it's possible that the quality. You're talking about the quality in particular, right? Quality in particular.
So the question would have been, if the same quality patent was going to emerge regardless of the existence of a GMI, would it have emerged faster? Because I think the question you're asking is actually a stronger question. It's a harder thing to happen. There must be, in the way, I'm not very familiar with this literature, but it's almost assuming that there is something inherently different about the GMI that would be linked to the emergence of the idea, which may be the case, I don't know. But to me, it sounds like the question that asking it differently about the timing is a slightly more lenient way that could help you generate further ideas.
Okay, I might follow up a line with you on that, because I want to make sure I got it, but I think that's a great point.
Sure.
If that's okay with you. Thank you.
Of course.
I think Lucien has a question.
Oh, yes. Thank you. Great presentation. So I don't know if I missed something, but are you able to observe the gender of the inventor? I don't know, would be interesting to look at how the point estimate or may change depending on the sex of the inventor. So I don't know.
Yeah, well, that's kind of a little bit what I meant here at the very last line. So like that I went very fast, so you didn't miss it. Like, we might want to look a little bit more into demographics. So I don't think we don't have the gender, but maybe with the algorithms and the names, we can do something to infer gender.
Okay.
And we definitely would that's something I'm definitely interested in.
Okay, thank you.
Mm-hmm. I think Jeremy has a question.
Yeah, thanks. I think this topic is really interesting. I'm wondering if, as you work on this more, you can say more or push forward on what drives the emergence of GMIs in the first place. So I'm wondering, are GMIs, this is related to heterogeneity by, the characteristics of the country of origin, but are GMIs more likely to come from countries that are more, say, advanced in the industry where they are then patenting in? And if so, why are they migrating to patent? I think these sorts of questions are interesting. I'm wondering if you have any thoughts about that.
Yeah, I mean, that's super interesting. We have some thoughts, but more like from the identification part, right? Like trying to see if there's something that could explain these movements, you know, in ways that is not related to anything else, so that we can exploit a little bit of that. But I don't think we have, I mean, I think it's a good question. I think there's a lot of information we could do to get there. It's all gonna be very endogenous, right? As we have it, but it's yeah, certainly a good direction to go. So I took note. Thank you.
Yeah, thanks.
Mm-hmm. Yeah, I don't know if there's any more questions. I want to be respectful of everybody's time.
So I will again come back to my earlier question. Like, do you have some sense about what are the push or pull factors when it comes to GMIs? Like, are they being attracted or are they being pushed out? Maybe financial crisis or recession during period in Latin American countries and all are playing a big role in pushing people out of the country. Like, do you have some intuition about that?
Yeah, I mean, I just this is kind of the universe of inventors, right? So to some extent, so there's certainly there has to be some. We haven't explored this very much, so there has to be some cases in which we can explore some push and pull factors. It's probably not going to apply to the whole sample, and that's something we could certainly look at to see if there's. I think the main challenge there is that because most of the inventors are actually located in the few rich countries, which there's not going to be a lot of variation of like political. I mean, who knows? I mean, after what happened the past 4 years, who knows? But there's not going to be a lot of variation, I guess, on if you're thinking about identification, which is what I'm thinking, because most of them are either going or coming from the rich countries.
Yeah, so that I was thinking like maybe like segmenting your data along similar countries, like movement among similar countries versus countries which are very dissimilar. So on economic criterion, like maybe movement from OECD countries to America versus to countries like India, which is quite poor, and how does that impact the quality of patents? It will be very nice to see.
Yeah, we can look into it. I mean, the closest to that is kind of that table I show you very fast, where we're seeing like the effect on when we only look at non-OECD countries. That was like the magnitudes were higher. But yeah, there's so much we can do with this, and that's a great direction. Yeah. I agree. I mean, these are all super great comments. I so much appreciate all of them, really.
Yeah. Thank you. No, it's a very interesting work. Thank you.
Thank you. Next time I'll come in person.
Thank you very much. And I think for other questions, so if you can contact Dany, we can circulate the email and so for everyone. Thank you very much, Dany.
Bye everyone. Thank you.
Bye.